right? This shadow we are positive integer again. So which have n positive strip. So we are given this array which have n positive strip integers. An array n positive integers. Then what we have to do? For each element ai, its shadow vi is sum of all elements a that are smaller than ai. Cool. For bi means sum of all elements, sum of all elements which are less than ai for some index I, right? This bi tells us that this is shadow element, right? This shadow bi. Cool. This is its mathematical form. You are given shadow array b. Your task is to reconstruct lexicographically smallest valid array, which consists of strictly positive integers that satisfy above condition. If no such array exists, output -1. Cool. So here we go. Third thing is we are given this B array. This is given to us. Right, this array would be given to us, and we have to find the lexicographically smallest array A, right, such that it follows this P. And if we cannot find any array, we have to return -1. Let's see the constraints. N is 2 into 10 raised to power 5. And all the elements are less than or equal to 2 into 10 raised to power 40. Okay. Yeah. So n here is less than 10 raised to power 5, greater than or equal to 1. And each element bi is less than or equal to 2 into 10 raised to power 14, I believe, right? And greater than or equal to 0. Let me cross check. Yeah. And it's 2 into 10 raised to power 5. And sum of all elements are sum 14. This is our b, right? This 0 tells us that sum of all elements, right? Sum of all elements less than x. So we are finding the largest negative number, right? What's the smallest negative number, right? And we are subtracting it from our current, which is a current number, and we are pushing it. This is the same part that as I explained. Now, for adding positive numbers greater than this is uh, 0. That means we are observation based. So here, what we are right. So we can also keep pi all elements less than it. Sum of all elements less than this. These should be less. Be equal to a1 for every I from 2 by chain. This 2 and assign this 2. Now let's move to this. Let it be z. AI for some index I. Right. This bi tells us that this is shadow element, right? This shadow bi. Cool. This is its mathematical form. You are given shadow array b. Your task is to reconstruct lexicographically smallest valid array, which is consists of strictly positive integers that satisfy above condition. If no such array exists, output -1. Cool. So here we go. Third thing is we are given this B array. This is given to us. Right, this array would be given to us, and we have to find the lexicographically smallest array A, right, such that it follows this B. And if we cannot find any array, we have to return -1. Let's see the constraints. N is 2 into 10 raised to power 5, and all the elements are less than or equal to 2 into 10 raised to power 14. Okay. So n here is less than 10 raised to power 5, greater than or equal to 1, and each element bi is less than or equal to 2 into 10 raised to power 14, I believe, right? And greater than or equal to 0. Let me cross check. Yeah. And it's 2 into 10 raised to power 5. And sum of all elements are sum of all n is 2 into 10 raised to power 5. Does not exceed it, basically the typical constraint that we are given. And we can either output the array, otherwise we can output the -1 instead. Cool. Let's using this example 0, 4, 0, 4 and 14. Notice something, what we have to do here. We have to basically, this is our B, right? We have to make some array A such that, let's say if this is X, right? This 0 tells us that sum of all elements, right? Sum of all elements less than X, strictly less than X. This 0 tells us, right? And if this is 0, that means this is the smallest element. Right, because the sum of all elements less than X is 0. That means this is the smallest element, because all the elements in A should be greater than 0, right? Because they're strictly positive. So this is our first observation, that basically if Bi is equal to 0, this means Ai is smallest element. Cool. How many elements I have with AI 0? 2. That means these two will be X. X is the smallest element now. Cool. This is 4 or 9? This is 4, right? Yeah, cool. This is 4. Now, for this 4, let it be Y, right? And if this is Y, this will also be Y. Why? Because if they both have same BI, this could be our second observation. If same BI, it's pretty evident, right? That if you have same BI for both, that means both element will be equal. Both element will be equal. That's why their sum of all elements less than it would be same, right? Yeah, that's cool. Now, how can we solve this, right? We made two observations that if bi is equal to 0, this is the minimum, and if it's not, like these are equal. Cool. That means this would also be y, right? And how are we going to basically make the elements here? Again, 0, 4, 0, 4, and 14. I assigned a variable x here. That means this is the least number. Why? Because bi is equal to 0. And here this is y. Both will be y. Cool. Now we know that sum of all elements less than y is equal to what? It's equal to 4, right? That means sum of this x and sum of this x plus x would be equal to 4. So this 2x would be equal to 4, and x here would be equal to 4 divided by 2. That means x is equal to 2 here. Right? Using the previous number, I got the value of x.
This is Valorant. Aren't you tired of playing FPSs where teamwork is non-existent? Then you should play Valorant. It's free.
Cool, because the sum of all the previous elements are given. Okay, cool. I assigned this 2 and I assigned this 2. Now let's move to this. Let it be Z. Is there any other 14? No, there is not. Now what we can do here is basically, what does this 14 tells us? This 14 tells us again sum of all elements less than Z. And that will be all elements of X and all elements of Y. Right? Because it's in increasing order, right? This 14 is the largest number, largest sum. That means they are the sum of all X. What is the value of 1X? We know it's 2. The sum of all X would be 2 into 2. 14. Cool. This divided by 2, if I take cool, so Y is equal to 5. So now what elements I got? I got Y. Y is 5. Cool. Now I don't have any other element. What could be the possible value of Z? Z. Also, one more thing. Now I have to assign the value of Z. I can assign it anything. I can assign it infinity. It does not matter. I can assign it 100. I can assign it 10 raised to power 5, whatever values we have that we have to correspond or that we have to follow, right? But we are given this condition that it should be lexicographically smallest. Right. For all values of x and y, we calculated it mathematically, right? We cannot change them. But for z, as we have a choice, we will take the lexicographically smallest value. Right. And we also know that this z should be greater than x comma y. Obviously, right? As this should be greater than that means I can put it as whatever y had, or the largest value y plus 1. So y was here, I think it was y was 5, right? So this I can put it 6. So our final value would be of x, y, and z would be 2, 5, 2, 5, and 6. Here we go, 2, 5, 2, 5, and 6. Now you can easily observe this, right? In the observation itself, we solved it. Right. In observation itself, we like how we did it. First thing first, there are few things that we have to take. First, we have to take the least value of b and solve for it. Then we can take the second least value. We can go in increasing order, right? And for every value, right? Let's say for this itself, for let's say 0, sorry, yeah, 0, 4, 0, 4, and 14. We'll take the least possible value, assign it as x, right? And then move forward. For 4, right, now we have a sum. Whenever we have sum greater than 4, what we can do is basically use this itself, right? That means that if sum is greater than 0, really sorry. If sum is greater than 0, or sorry, just give me 1 minute. What am I doing? Also, we have to move forward.